Okay, so calculus, rate of change. Now there's a couple of rate of change that you need to aware of, which is average rate of change and instantaneous rate of change. Okay, now can you see, can you spot the difference really? So one has 2 points going through there and the other is just one. Yeah, that's a big difference from like visually. And also look at the formula. Average rate of change has 2 points, like a difference of y values, which is a q, and difference of x values, which is t's. Yeah, and here it doesn't really have that 2 points to the difference of those 2 points. It's just finding a well, d is sort of like a change of q and the change of t. So it's a rate. Okay, rate of change. So just basically just remember to think about that this is like 2 points, like a secant. Like what secant is the line they go through 2 points, whereas this is a tangent and going through one, not through it, just touching it at 1 point. So that's basically what it is. Now, before we start the questions, you need to know 3, different meanings here. And we're going to use a displacement now, not distance. Now, this is sort of distance, but displacement is the distance with the directions, positive and negative, like, going to the right or going to the left, directions. And velocity is a speed with directions, going to the right, it's going to be, positive velocity, going to the left, negative velocity. Now, just be careful with what, there's some notations, all this happening here. Now x now is not x-axis no longer, it's displacement, which is distance, which is the actually y-axis. Okay, so be very careful about what from here on, think about what the meaning of the x and a v and an a. Velocity, v is differentiation of displacement, so it'll be dx over dt, and then acceleration is the dv over dt, and x little dot there and x of double dot there for acceleration. Now, easiest way I could think of, you can memorize this, displacement and the velocity is the gradient of the graph of the displacement and time. So for example, something like x and t, the gradient of that is velocity, and gradient of v and t is our acceleration. Okay, so just remember that. All right, then let's go to the question. Okay, so first one, part A, the number of bacteria in a culture increases according to the function b equals 3t to the power of 4 minus 2t squared plus 1000, where t is time in hours. Find part 1, the number of bacteria initially. Okay, this is the key word here right there, initially. What does that mean? It means at the beginning t is 0. Okay, so at the very, very beginning, nothing happens. How many, things are there? Like a number of bacteria. So b equals 3 times 0, because t is 0. 0 plus 1000. Yep, you guessed it, 1000 bacteria. Yep, excellent. Part B, the average rate. Yes, so if you think about it, average rate was like a secant of 2 points. So there's of change in number of bacteria between 2 and 3 hours. So these are the actually t equals 2, t equals 3. We need to get how many bacteria when it's a 2, when it's a 3. So then we will get 2 points, like a secant, yeah? And then we have to find the average rate, so it's a gradient. So if I put it in a calculator, I will get this. Excellent, so we'll get 2 points. So average rate equals the difference of the B's, 1, 2, 2, 5, take away 1, always take away from the bigger one, 3, take away 2. So what do we get? Put in your calculator, you will get 185. What is my unit? Because it's a rate, we'll get 2 different units. Bacteria per hour. Excellent. Next one, the number of bacteria after 5 hours. That's not too bad. This is just finding a using the formula 3 5 power of 4 minus 2 5 power of squared 2, and then you will get 2,825. Okay, so that's what it is. So T was 5. That's what we have to find. Okay, next one. All right, so the rate at which the number of bacteria is increasing after 5 hours. Okay, so we should get a positive number because it's increasing. Now this is the rate that we need to do dB over dt. So at t equals 5, that's what we're looking for. So I'm going to have to differentiate this. My original equation was minus 2t squared plus 1,000, and I'm going to do dB over dt, which is 12t cubed minus 4t, and then it'd be 0. Yep. So, and then I'll substitute t equals 5. So 12, 5 cubed minus 4, 5, and when you put it in your calculator, you will get 1,480 bacteria after 5 hours. Okay, so that's done. All right, that wasn't too bad. Really, it wasn't really that bad. Okay, part B. An object travels a distance according to the function d equals 3t squared minus 2t plus 6. Now, this is like a quadratic, which is parabola, where d is in meters and t is in seconds. Find the speed at which it is traveling at 5 seconds, 12 seconds. Okay, so speed, it's like a velocity, right? And the graph of the distance and time, this will be gradient, and it's only at one point, so we are looking at instantaneous rate of change. So it'll be d over dt. That's what we're looking at. Okay, excellent. So, and t equals 5 here, t equals 12. So the velocity, the speed is dd over dt. So if I differentiate that, I will get 6t minus 2. Okay, ed over dt equals 6t minus 2. And when t equals 5, 28, and meter per second. So don't forget, it looks like yep, and that one is 612 minus 2, we get 70 meter per second. Okay, so that's not too bad. That was easy. Okay, so second question. A ball rolls down a ramp so that its displacement, x centimeters in t seconds, is x equals 25 minus 2t squared. Again, it's a parabola. It's concave down. Okay, so that's not too bad. Doesn't look that complicated. Find its initial, there you go, initial displacement. That's t equals 0. So x equals 25 minus 2, 0, it'll be 25 centimeters. Okay, so that's all good. Find its displacement at t equals 3. That's not too bad. 25 minus 2, 3 squared. 25 minus 18 equals 7 centimeters. Okay, find its velocity. Oh yes, that's a rate. So I've got to do dx over dt equals, so what was the equation? 25, okay, that will looks like minus 4t. Yep, at t equals 2. So my velocity will be minus 8 centimeters per second. All right, the next one, show that the ball has the constant acceleration of minus 4 centimeters per second squared. So we're looking at A equals, which is dv dt, which is also dv dt, yep, equals minus 4. That's what we have to prove. Okay, so that's equals, yeah. So if I do dx dt was minus 4t, wasn't it? And if I continue with that, so that was a v, and I'll do dv dt, that would be minus 4. Yeah, that's the same as that. So centimeters, you can write it like this instead of minus 2. So your answer should be acceleration is constant at minus 4 centimeters per second squared as required. Okay, great, well done.